Right. So good afternoon, everyone, and thanks for being here. It's the after lunch session on the last day, so I appreciate everybody who's sitting here. Um, let's get started with the agenda. My name is Raj Nair. I'm the Director of Data Platforms at Penton Inc., and I'll talk about the company in just a bit. And with me is my co-presenter here is Kiru from Serendio. He's the CTO of Serendio. He's our technology partner, and he'll talk about Serendio in a bit. This is the agenda that we're going to take you through today. We will briefly describe the business. I'll describe the business that we are in and the challenges that we faced in our business. And we'll talk about how we address those challenges at Penton through a use case. And Kiru is going to walk through the use case and the implementation and the functional aspects of the use case and how we basically move to a big data architecture. And then some lessons learned from our experience going through that, and we'll wrap up at the end. So about Penton, many of you may not have heard of Penton, but we've traditionally been in the publishing business, but we have recently been rebranded as a information services provider. To give you an example, these 5 markets are where we actually operate in. So we provide actionable information to these 5 core markets. These are some of the examples of the kind of products we provide. So essentially we do 2 things. We have a traditional content business, so we actually create and publish content for these 5 industries. And now we also do what we call is our more profitable business, is we actually sell information back to these industries. So we are kind of like, the best way to think about us is we are like the Kelly Blue Book for other industries. So we provide valuations on aviation, on fleets, and heavy equipment. So in our industry, valuation accuracy is gold, because that's why people come to you, right? You go to Kelly Blue Book because you get the best valuations about cars, all the way back to 1990 or whatever, right? So that's kind of the business we're in, those 2 business models. We have content creation and publication, and we have data products. These are some of the products as examples. The top 2 are our more popular products. Govalytics is actually a analytics product that actually provides you analytics on government capital projects. So it's very useful for people who work with government to know, to get an analysis of how the government is spending on capital projects. Source ESB is another vertical that we have. It's a vertical directory. It's essentially a product that allows you to search for electronic parts, and it's B2B. It's not for consumers. It's business to business. So we have distributors who give us pricing and inventory information, and other businesses use that to basically build up their inventory. And I'm going to let Kiru talk about Serendio.
Serendio, we are a big data solutions provider. We are basically a HBase shop. We specialize basically in moving appropriate SQL applications which don't do well there, or where SQL is not the right platform, to HBase.
Right. Okay, so let me talk about what got us thinking at Penton about rethinking our existing implementation, existing architecture. These are some of the problems I think are probably common to many other companies, not just Penton, but we have a heavy dose of this. The main challenge for us is organizationally, we have business units that just operate in silos. Each business unit basically processes and manages data their own way. We do a lot of heavy ETL, and each business unit, it's a spectrum from taking a few hours to days to process this information. And I'll talk about that a little bit in more detail. And we realize that we're not even using all the data that we can or we want to use. We're not logging what we are using. There's a lot of instances where the business wants to know what happened in the data processing, and we just can't provide that information. And ultimately, we just can't scale for future requirements. So this is kind of like the tipping point for us. Is we are going through all this, and we realize that if we keep moving forward the way we do things today, we're going to basically crumble a little bit. We're not going to be able to scale. So this visual is I'm going to give you a brief idea of what the meat of the issue is. For us, the data processing pipeline is our biggest headache. I mean, that's the number one priority for us to solve. And when I say data processing, I'm sure this happens in other companies, for other people in the room who might be familiar with this, is data processing for us is where we actually bring in a lot of sources on one end. We push things through this pipeline, we have to clean them, we have to ingest them, we do some assembly line processing, and at the end of it, we want to, essentially what do? We try to produce some business value, right? And for us, business value is normally in the form of new features or hopefully new products or maybe new insights, right? So simplistically, what we have is we have sources on one end that we have to pass through a pipeline so that we can come out with business value at the other end. And I have put some things along this to show you what some of our issues are, right? When we bring in sources, the first thing we do is what we call shoehorning. And the shoehorning means that we got raw data, and before we even work on that raw data, we basically change the format and put it into a relational database, right? A step that I think is somewhat unnecessary given the technologies and tools we have today. And then once you put it in the relational database, now you're constrained by the capabilities and the features of that database, right? You can only operate on it what the database allows you to do and how it does the processing. And then we stage the data, and then at the end of that, we load it into another database that services a web application, which is essentially a product. And then we spend cycles performance tuning that because you never get it right the first time. So this data processing pipeline for us, if you think about it, is actually a function of time and money, right? Everything that you do in this pipeline, the longer the pipeline is, the bigger the cost of doing business for us. And all our business units have a lot of data that they need to process through this pipeline. So this pipeline is one of our biggest bottlenecks right now. And at the end of it, today, in terms of business value, we basically do good with new features. I mean, that's what we really get out of a lot of the pipeline. Where we want to get to, obviously, is more new products and new insights, which I put question marks around those because those are today really not happening at the rate that we want it to happen. So the goal, the vision for us is to say, okay, let's start with the data processing pipeline because this is our biggest headache, and let's change it to something that looks like this. Not only do we crunch the pipeline, make it smaller so that we can bring out things faster, but let's also add the support to add more sources, more data as input, and produce more value, business value as the output. So essentially we want to, as a vision, we want to exponentially transform the data processing pipeline, not only make it smaller, but also make it consume more and output more. So that's the goal with the pipeline. And some examples of examples of data that comes in through the pipeline. The product that I talked about earlier called Source CSV, which is a directory listing of searchable electronic parts. We get daily inventory data, thousands of files from distributors throughout the day, and that's tens of thousands of parts that come in daily. Some other products, we have what we call auction and survey data that is gathered daily. This is essentially information about all the auction that happened on fleets, all the auction that happened on heavy equipment. We have to take in that data into this pipeline. And we do a lot of intensive calculations to come out with valuations on that data. So these are just examples of the stuff that comes into the pipeline. And the really funny part about this is, if you think about the things that we do through, all these are different business units. But if you think about the things that we do, in general, it's almost the same kind of processing that we do, right? We need to ingest, store, clean, and validate. We need to apply business rules. We need to analyze, report, and distribute, right? The only thing that's really different across these is the application of the business rules, because every business unit has a set of different business rules that they want to apply. So essentially, this is almost a framework that we are underutilizing, right? We don't, because every business unit does it their own way. So the goal of this is to see if we can create a more scalable data framework across these business units. And the business is also, for each of these, to do any kind of change, you need business support. And the business are seeing the issue, because when the ETL or the ELT or whatever is slow, it frustrates the business and they miss the SLAs. We miss our SLAs. So I think everybody at the table knew that we had to change the way we did things. So we had options. We looked at our options. The most across the business units, most commonly we were using Oracle and SQL Server both for data storage and also as the computing engine. So all our cleaning and transformation, everything was being done through a relational database. It's either SQL Server or Oracle. So we had the option of expanding, our RDBMS options. We use standard editions of SQL Server and Oracle. So we looked at that, and it's pretty expensive. If we wanted to start scaling, just moving up to Oracle Enterprise is an investment of $1.5 million, literally, right? And then you have to buy add-ons. You need to buy partitioning. You may need to buy on rack. And so it just started looking more and more expensive and complex. And on the other hand, obviously, we know that there are technologies that have come out in the market, like the Hadoop ecosystem, which is with the MapReduce that is really ideal for batch processing. And we had a lot of batch processing that we needed to control and scale faster. So obviously, we went with the choice of trying out the Hadoop ecosystem. So essentially, what we did was we took a use case of ours, and we used Serendio to help implement that use case. I call that a POC, but any POC is going to be successful, because when you take your own data and apply technology to it and see what the outcome is, you're going to succeed, because you're going to either know that it's going to work, or you know that maybe it's not going to work, right? So a POC, I think, from my perspective, is a very valuable tool. It's a very valuable thing to do. So now I'll hand it over to Kiru to walk you through the use case and the technology behind it.
Okay, this is pretty much this is a pricing application, right? You can think of it like your Blue Book, except that this is not for cars or anything. It's for forklift trucks, excavators, bulldozers, and things like that. So how do you find what is the resale value of a particular make, model of something? You first collect data on what price it is getting sold at auctions, what price it is getting sold to third parties, and there is also, in this particular application, they also collect rental information on these heavy machinery, because renting is one of the major use cases in that space. So this application does all these things, but the one task we had to conquer was just to handle the incoming data. So the data, this auction data, resale data, extra, they come in as CSV files. And there are analysts who upload these CSV files, and some massaging of these things happens, and then the pricing gets calculated. So we are going to deal, our project, this POC was focused only on dealing with these CSV files. So sort of ingest, then move it to the right tables, the cleaned up data, and we have to do it interactively. This is an interactive application. Like the analyst, the business person can load and massage clean up the CSV. They put something in the string for model. They can do those things. They can delete some rows, and then they can do it. So and then ultimately there is some aggregates which tell me how much data I have on auctions on this particular model, right? So there's going to be some analytics as well. So that's the use case. We're not going to talk about how the pricing is done and all these things. It's just we are only working on the input side of this application, right? So let me get into the functionality of what this application does, to just a brief idea, so that One of the main things that we do is you have to scrub the data. What does scrubbing mean, right? Like this is a CSV file and there's columns, like for example, for country, right? You have United States of America, United States. Same thing for many other fields. They got to be standardized to something, right? And that is one of the main things that we have to do, because when people collect this data, they input whatever they want from the field. So it's like field data that is in the CSV file. So naturally, the data has to be cleaned up. Another thing is when you collect the data, like for a Caterpillar truck or something, the application should have support for that manufacturer, et cetera, right? And models, et cetera. It doesn't do pricing on things it doesn't know. It cannot dynamically do things. So what we have to do is, as part of ingesting this input data into this application, is to convert these fields to IDs. So there's some kind of lookup happening. And when it comes to the models, there is some kind of fuzzy matching and partial matching that is happening. And sometimes they kind of collide, like two things are the same. They call it a collision. So you have to resolve those things where there is some interactivity involved with the analyst working with the app to clean up the data. Ultimately, the data needs to be exported. Earlier, it used to be called in Penton importing, but right now we call it exporting, because we are working on this side, on the HBase side, and moving it there. So that is actually, it's like a select insert into another table. That's what was happening earlier. So this is the three main aspects of the application, right? So how it is done with the current app before we started working on it, how was it done before we started working on it? It's like you take the CSV file, and actually the rows in the CSV file go into a table. If you add 1,000 rows, it becomes 1,000 rows in another table. And actually, all the CSV files go into one table. And again, you have to map it and scrub it using this table. And after that, you just, like I said, move it to another table. The thing is, not all the rows from the CSV table are used at any point of time. They could be used later on, because we don't have support for this particular model, or for the manufacturer model is not supported by this application, so that they may not do it. But you can say, hey, I don't support Blue Book for Tesla or whatever cars that come out, but later on, after 2-3 years, you might add support for it. But you can go back in time and get all your data back on this resale value of these cars or the machinery, and then do this thing, right? So the pain points is kind of like very obvious, right? Because the CSV data goes into a big table, and this table grows. Like even if you had around 20,000 files, 1,000 rows, it's like you have 10 million rows, right? So you're working with this large row. It may not be large enough, but still it is large enough so that it is causing some pain, actually. So, and also, Penton was expecting the data set size to grow a lot in the future. So we came up with some kind of criteria. If you're going to do this on big data or redo this part of the application, what is the criteria we should say, right? We just have to store an individual file, and this file needs to have some sort of CRUD on it as well, because we're going to clean some particular columns of data as well as delete the rows. So vertically or horizontally, we're going to do something with this data. That is one of the main things, right, we have to have, right? And it should also have integrate with the RDBMS, because the main app is running on Oracle, right? That is where the pricing model runs, actually. So it should, this thing. And one of the things Penton wanted to explore is, can I move the whole thing to big data platform as well, to another platform as well? So this platform, whatever you choose, should be good enough to host the current app ultimately in the future, right? And of course, this is all about analytics, and we should have very good analytics on this thing, right? This is the criteria we came up with, right? So So the answer, I think, that popped in our head is it's got to be some NoSQL technology, because we're going to store some blob of data, massage it in some way, and then push it out somewhere else. So obviously, what is the NoSQL technology on the Hadoop stack? Because we are a vendor who works on big data Hadoop a lot. So it's a natural choice for us was HBase. So let's see how this architecture looks with HBase in the picture. Right. So we store the CSV file in HBase, right? So we actually store the CSV file in HBase. We use rules for scrubbing. Actually, earlier it was all SQL that massaged these data, but Penton wanted us to go into a more generalized, robust framework where people can define rules for cleaning up the data, right? So that is all we put in, right? When you're doing these individual operations on these files, we just use the HBase put get APIs, right? It's, so we get the same kind of interactivity, right? Proper response the UI wants when it is dealing with these things. The data manipulation, even though it is done using the HBase APIs, is actually exposed through a REST layer, right? This is the REST layer. When we wanted to do the individual operations, when the analyst loads a file and is massaging, manipulating this file in the UI, we are doing this HBase gets and puts all the time. But at one point of time, say like for example, one day they decide, oh, we are going to support Caterpillar model this. And so let's go back and get any data we have on the, in our archive, right? So in that case, we would kick off MR job and do that thing. So I'm just going to jump into the app design right now, right? One of the key things in the HBase, it's a nice cliche, key, the HBase row key is the key to your success with HBase. Actually, if you read the book, Lars' book on HBase, whatever is there in the advanced usage is actually the minimum that is needed to work with HBase. So you need to know the row key very well, right? So what was the design choices we had when we did this, right? So we could do whatever was being done. Because we have a big data platform, we don't care about it. 20 million rows, no big deal. So we could just do the same thing on HBase. Or we could say we'll put one file in one row in HBase. So we went with the one file, one row. It simplified many things. I'll go over it when we come to the performance advantages. So we have one file in one row in HBase. I think at the HBase conference, it was referred to as the entity-centric design. You have one entity, it's in one row. Like we are working on other apps, for example, insurance. One claim is in one row. One mobile phone is in one row, right? Any details about a mobile phone. So, and there's another thing we want to do more detail on the schema is like you have in HBase columns and values, right? We could use each cell in the CSV, that is a row column, as one column, or we could just use one row in the CSV. Initially, we started doing this. It was very easy for us to put just one cell because we were using open CSV libraries to process the CSV. By the time it just gives us an array of strings in that column, so it was easy for us to put it in one column there. We went there, but I think for performance reasons, we could easily move to one CSV file row per column in HBase. So next thing is the row key design. As I mentioned, this is the key to your success is the row key. So normally, the row key is the main and the only way of accessing data in a performant way on HBase. And unlike in the RDBMS world, you can define your table and then later on put some indexes on whatever columns you feel like. So that is, you don't have that luxury here. So you need to do some planning beforehand and come up with a composite key where things that you want to access are there in the key itself. Like in HBase, you can do what they call as a partial key scan. That is, you're using part of this key to scan through this big table, right? So for us, for this project, the key is the users. There's business analysts, like a few hundred of them, uploading, right? They are responsible for collecting data on these things. So we put the ID, we put the type, whether it's auction data or it's because that's one of the main things the application deals with is the type. So that is something we put it into the thing, so we can look it up fast in HBase, right? We also put the date, so that the recency of the data is also very important, right? Like today, whatever we collected. So we usually look up what has been loaded this month, this week, or whatever, right? So that also we put it in. But when we put these three things in, it was not giving us a unique key. Because the user could create, upload multiple files in a day. Because if you see our date, it is only up to date. So we put a GUID over there, which gives us a unique way of getting at the row. Actually, that alone would have been enough, but we have this composite key mainly for the reasons I told earlier. It's like accessing based on some column values, which otherwise would have been a column value. And then after we did these things, we got a doubt. Is this key good enough to be distributed across all the regions, right? So otherwise what happens is when you insert something, the row will go into one particular region, and that region will get hotspotting, right? So we don't want that hotspotting to happen. So what we did is we added a 1 byte prefix, right? So, and then I think we have a modulus 32 on it. So at the best, we hope it will be 32 nodes or something like that. So the data will at least bucket into 32 buckets, right? So that's pretty much about the row key design. We'll go into more how we use it. When it comes to the column families, like in HBase, the column and values, they're kind of grouped, right? And a column family is actually the storage on disk. Basically, that is actually the table. If you come from relational database technologies, and that's this unit of storage. The column family is the unit of disk storage. Actually, in Cassandra, they actually call it a table. And instead of it used to be called family, they call it a table right now. So we separate out. So now you have some data. You read, you infer something from it, you calculate something from it, you store it. So you read something, you write something, and things like that. So what we did is we separated these things out into column families. So we did it into 3 column families. One containing the actual CSV file data. In one, we have some kind of mapping data, like for example, like Caterpillar, manufacturer ID is 25. The mapping between the Caterpillar 225, that is stored in another thing. So we basically do not really modify the data as such that the rows are just there in one column family, and the mapping information is there in another column family. But whenever we want to move data, we can convert it on the fly and move it, right? So, and another thing is, in the main column family, one feature that we sneaked in while doing the project is that, like when people collect the CSV file data, they get more information than what the application does. They could collect more information, like for example, condition is there, but they could add more cosmetics for example, cosmetically how it is, like whatever, right? But right now the application is like, because of the fixed schema in the relation database, they throw that column never goes into the database. It's kind of thrown away. But whereas with the HBase app, we just store, when you throw in this CSV file into it, we just store row 1, column 1, row 1, column 2, like that. It's like keys L1, C1, L1, C2, like that. That's what is there in one column family. Other is the mapping. Another one is basically metrics, where we successful in mapping one row. Do we know about all the manufacturer models, country, currency, condition, everything, right? That is there in another row. So that's the key to your performance on HBase is to group them into column families so that you don't really bring in all the data when you need only a subset of the data to do whatever you want, right? So what are the jobs we have doing? So we talked about many of these things like upload is like just a put, right? Delete is just a delete. And anything they do with the manipulation, it's all like HBase APIs. But we also have map-reduce jobs which run in a batch mode kind of thing. So we could do it for scrubbing. So when we upload, we actually fire rules. We actually put the file once so that the version 0 of the data is exactly like what the user had initially. And then we scrub it, let rules fire the rules, it modifies it, and then again we put it, right? So we can do this scrubbing, this mapping, everything in an MR job. So we can do it, so like we can kick it off from the UI, or we can do it from Uzi as well. Another thing is we have some scoop jobs. We have this database. So what we do is we already have data. I mean, Penton has been collecting data for years about machinery resale data. So when we migrate to the HBase app, we need to migrate from that table. So there is a one-time scoop job which will migrate those data into HBase as well. And there's also rules they have. The rules are all defined using regex and some SQL. So we have a way to import those rules and put it into this thing as well. And another thing is we have this lookup data, and of course the lookup data also has to go because we don't want to go back to the RDBMS all the time, right? So how do we integrate this? As I mentioned earlier, we use REST layer. We are running on Tomcat. So this REST layer gives us flexibility because the front end is PHP. We have REST layers that deal with CSV files like update, delete, list, and all those things. And we also have the things where you can create rules and for your data scrubbing and other things. So what did we learn from this, right? The performance is, of course, is very good. Like, for example, like I said, like 1,000 rows, 1,000 rows in one CSV file, and 20,000 is 20 million. So whenever you want to upload another file, you are thinking about like 1,000 inserts into a 20 million row table, right? So now it's just a put into HBase, which is only 20,000 keys. So it's like 1/3, and that too, these numbers are in our dev environment, which is virtualized, right? It's not real, it's virtualized, and this will be. So the metrics, whatever we were doing earlier, they used to show so much auction files and all those things. They were all in materialized views in Oracle. Right now, we can do aggregation on 20,000 row keys on HBase very easily. We use some co-process for that, but it's still very good. And upload, delete, and all like really, really fast, right? What are the things we had to tune in HBase? We had to tune the heap size. We put some compression. The small files, we have to make it in memory because they're too small for HBase. HBase is better off dealing with big files, right? So we do that. What are the challenges, right? Like, see, we're working with like sort of a J2E app, like real app people build with browser, app server, database. And now, under the covers, we are redirecting part of the application to go towards big data stack. That's kind of a challenge. Like they were like UI had like pagination for all the files. So imagine like paginating through like millions of things, rows in HBase, right? So that is something. So we had to do some pagination. We just did, there is something called page filter in HBase, but it didn't really work very well with the fuzzy row filter we were using. So the fuzzy row filter is another cool thing that we used, and I think you should check it out. If you're into HBase, you really need to know your filters, right? So you do that. So the thing is like, translating the queries, initially I thought, well, it's just lookup, what's the big deal? But that itself was a lot of SQL, right? A lot of SQL that needs to be do that, right? Again, no secondary indexes. We use fuzzy row filter. Maybe we should have used something like Phoenix, but I didn't want to bring in too many technologies in here at any point of time. Another thing is when in HBase, when you're reading and writing, the compaction is like done across all column families in 9.4, 0.94. But I think with 7236, HBase 7236 in 9.6, HBase 9.6 later, you could set up these policies, what gets flushed, what column families should be brought on demand in there. So whenever we are going to do the next benchmark, we will do with HBase 7236 as well. There is issues with the lookups. I'll come to that. The lookup tables, there's a lot of the small tables causing a problem. Again, the value proposition was very obvious. We didn't even have to benchmark. Just by using the UI, you could see it like the operations are much faster and things because, like I said, like putting into 20,000 keys in, for example, in HBase versus 20 million rows on Oracle. We could scale out the batch processing when Penton wanted it to be like less than an hour. You could add more nodes, horizontally scale it out. And the stores, the CSV files are like on a redundant storage. And one thing, when the data was being cleansed and worked on by the analyst before it gets moved in, there is no way to do that, but we have a way to track it right now. Again, we want to move to 9.6. Maybe instead of the core process I should be using Phoenix, right? Lookup data tables. Yesterday, I was in a presentation. There was something called HBase 10070, which gives us replicas on these things. So we could replicate these lookup tables on all the nodes, and it'll be faster, right? Again, pagination is not good when you're dealing with an HBase application. People should think of a search-oriented paradigm. So there is not only the backend, in the UI also, you have to think how you're going to deal with big data. So that's a thought I want to leave you guys with. Let's wrap up, and I'll have Raj.
Hello. Yeah. So to wrap up, I think these are kind of real-world issues, kind of real-world problems that you face when you start using big data in your environment. For example, what Kiru described, was a challenge because our analysts had an admin backend UI that was being used to do the same kind of things that we do as batch process also. So the analysts had the ability to, through the UI, do cleansing, through mapping, and they run these business rules through the UI, and you get buckets of mapped and unmapped files. You also want to be able to do that in the batch process. So the big challenge for us was the fact that we had an admin UI that was interactive, and I think they did a tremendous job coming up with a solution that addressed that. In the end, the POC really demonstrated the value of the Hadoop ecosystem, right? Obviously, it addressed parts of the pipeline that I showed you, right? We're not shoehorning the data anymore. And there is opportunity for coexistence of big data technologies with current solutions. Because in this particular example, the web application was still being serviced by RDBMS. But what we did was we took out we relieved the workload on the RDBMS by moving out the transformation, at least in this use case, to something that does it better. So we found basically the adoption of big data technologies for us can significantly improve the scale. There are new skill requirements, but that is a challenge I think will be addressed through the market. And I think that's about it. And to conclude, I would like to open up for questions.
If you have any questions, just raise your hand. I'll bring you the mic.
All right, no questions?
Any questions? If not, thank you for coming. Okay.
There's a question here. Thank you.
Did you think about your CSV like changing over time, like the structure? You receive a file, you have 5 columns. Sometime down the line, it's added a 6th column. Let's say at some point you extract your history, and then you have end up with files with different structures?
Yeah, we did think about it. We plan to leverage the HBase version. So we have the max row, max columns fields in that. So if you go to that, the versions of these columns, we can know that how many rows were there in the first version, how many rows were there. So we could use this versioning, but the feature is not fully developed XR. But we have enough capability in there to expose it in the future.
Thank you.
Thank you all.